Okay. Okay, so today we're just going to continue with some more things which I think you probably are familiar with, even if they're given different names and stuff. First thing is in 1.7, this thing called symmetry. Right? Symmetry is something that human beings have some sense of. Right? We feel like people are symmetric, right? Or left-right symmetric, or faces are sort of symmetric. People seem to like things that are symmetric. So the question is, how do we describe symmetry mathematically? Right? How do you describe it mathematically, rather than saying, oh, it's that thing where if you reflect it, then it looks the same, right? Right. So I'm going to draw some silly pictures here. Sorry. I did these a couple of years ago, and I should probably change them. But, anyway, so like here is like something that has symmetry, and here's something that has another kind of symmetry. Here's something that has another kind of symmetry, like this. See, these are all sort of symmetric objects. Okay. And so, we have some sense that there's some symmetry going on here. How do we describe it? So, describing the graph, if we describing the set of points, we notice that every point that's in here, let's call this set of points G. Okay, the collection of all the points in this graph. It's not really a graph actually, but the collection of all these points in this set here. Actually, it's a graph. So we notice that if a point is in the graph, then something happens. This point is also in the graph, right? And vice versa, right? If some point xy is in the graph, then the point negative xy is in the graph, right? And so maybe that's one way of describing this sort of left-right symmetry, right? And then describing this sort of symmetry, what do you notice? Well, a point is in the graph, xy is in the graph, if and only if x negative y is in the graph, right? Every point, you take any point here, any point in the graph, and you notice that the guy with the same x-coordinate, but the opposite, the negative y-coordinate is in the graph, right? And this one has sort of this sort of symmetry that a point is in the graph, if and only if negative x negative y is on the graph. And so these are ways of describing this intuitive idea of symmetry that we have. Right? So that's another way of describing the symmetry. You notice in the set of points, right? So it shows up, symmetry shows in the description. Or maybe I should just say in the set of points, right? There's this relation between the points. Another thing is probably you've seen this before, that algebraically, if you have some equation, shows in the equation, symmetry shows in the equation. In the first case, if you replacing x by negative x doesn't change the equation. In the second one, replacing y by negative y doesn't change the equation. And in the third case, replacing both x by negative x and y by negative y doesn't change the equation. and if that's not clear at this point, let me just hold on a second and we'll do some examples. This first symmetry is called about the y-axis, right? About symmetry about the y-axis, symmetry about the x-axis, and the last one's called symmetry about the origin. So that's how we call them. Right? Symmetry about the y-axis, symmetry about the x-axis, about the y-axis, about the x-axis, and about the origin. So let me just do some examples. So here's an example, say y squared is equal to x. Right? Y squared is equal to x, or maybe let me do this one. Y is equal to x squared, sorry. Y is equal to x squared. So you look at this, and maybe if you couldn't see it, if you didn't know what this picture looked like to begin with, you'd say, okay, well, I can check to see what kind of symmetry this thing has by playing this, by playing these things. I say, okay, well, if I replace x by negative x in this equation, does the equation change? And the answer is no, right? You say, well, look, if I say, if I take negative x instead of x, then I basically get the same, equation, right? Because negative x squared is the same as x squared, right? So it's immediately you look at it and you say, okay, well, I've got it's symmetric about the y-axis, symmetric about the y-axis, right? Or if I have something like this, right? Y equals x squared plus x to the fourth plus 5 x to the eighth, so, right? And I say, okay, well, what do you see immediately from looking at the equation? What kind of symmetry does it have? Symmetry about the y-axis also, right? Because it's got, if I replace the x by negative x, right? So check. If I replace the x by negative x, negative x squared, negative x to the fourth, negative x to the eighth, right? But these are all even powers, and so when I square them or quadruple them or whatever, I take them to the eighth power, then I get the same thing, right? And so even if I don't know what this looks like exactly, I do know that it has a certain symmetry, right? Both of these guys have symmetry about the y. Both of these, the graphs would be symmetric about the y-axis. Right? If I had something like, say, y squared equals x squared, what kind of symmetry does it have? Think about it for half a minute. Do you have a question, Caroline?
No.
Do you have the answer?
Yeah.
Okay, who would like to say? Caroline, please.
Could be symmetry about the x-axis and symmetry about the y-axis.
Okay. you notice if you replace the y by negative y, nothing happens. The x by negative x, nothing happens. If you do both of those, nothing happens. Yeah.
So can it be symmetry without the origin without being both symmetry without the y?
Okay, so let's look at this. Say, y equals, say, x cubed. Let me do a different one first, and then I'll get to one that answers your question. Just look at it. What is it? What kind of symmetry does it have? You notice if you replace the y by negative y, nothing happens. If you replace the x by negative x, on the other hand, something, it does change. Right? So it doesn't have symmetry about the y, but it does have symmetry about the x. Right? If I replace y by negative y, well then I still get y squared. So it's symmetric about the x, but not about the y. What about this one? And it's a good question, Sophie. A very good one. Is it true that being symmetric about the origin means that you're symmetric about the x and the y? Certainly it's true the other way, right? Right? No fat means no flavor.
Graphically, it can't be true.
Right, graphically, you know, that's not true. And here's an example of how it's not true. Right? This guy, is it symmetric about the x or the y? No, because when you replace things by negatives, the equation changes. Right? But if you replace both of them by their negatives, well, you end up with negative x equals, negative y equals negative x cubed. You multiply both sides by negative 1, what's legal? Right? And the solution set is the same.
So that's, which rule is that?
This one is not symmetric about x or y, but is symmetric about the origin. Is symmetric about the origin. Okay. Those of you who know, right, the graph looks like this. Right, the graph looks like this. And if you take a point, every point on the graph, if you take the negative of the x, and the negative of the x and the negative of the y, you get another point on the graph. Right? But you see that it's not symmetric left, right, or up, down. Let me make you think about one. Here's the equation for a set. Take a minute or so and tell me if it has any symmetries. Alex, go ahead.
Is it all three? Because it doesn't matter if it's negative or not, because it's just how far away from
Be
zero.
careful. Right? If I replace the x by negative x,
Yeah.
well, I'm actually changing, you know, that's quite a different equation, right? But you're sort of hoping that this the same thing as this? Right? If that were true, then it would have a symmetry about the y-axis.
If I know what it looks like on a graph, can that help me? Because I know it's sticky, or it's an absolute.
Well, so let's just think about it. Let's think about it just from here, just algebraically. Okay, because your graphical intuition could be wrong. Okay, so are these two the same thing? No, right? There's no rule of the absolute value that would make these two things the same, right? Or if I replace the other guy by negative y, you know, that's not the same either, right? What if I replace both of them by negatives? Is that the same? Are these the same thing? Does the equation change?
They're the same?
They are the same, right? Because right, you can pull out a negative 1. And this is negative 1 times x plus y. Right? And the absolute value says, well, the absolute value of the product is just the product of the absolute values. Right? So this negative 1 becomes a 1. The absolute value of negative 1 is 1. And then so the left side is the same thing as the original left side. So this thing has symmetry about the origin also, but not symmetry about the x or y axis. So anyway, so that's maybe all we want to say about symmetric things. Sort of to make a rather forced connection, since we're talking about symmetric things, why don't we just talk about circles? So that's a very tenuous connection, but that's what we're going to talk about next. Okay, so what's a circle? Circles. Right. What is a circle?
It's round. It's round.
It's round. Okay. How do we describe the circles? Like from some point, right? So it's a collection of points, right? It's all points of equal distance. Some same fixed distance from a fixed point, the center. Right? That's how you describe it in English. Right? So, and in math talk, you would say, well, there's some fixed point x naught, y naught, the center, right? And then there is some fixed distance, d, say. And we're going to look at all points that are of distance d, right? So all x, y whose distance from x naught, y naught is d. Right? All points whose distance from x naught, y naught is d. That's how you describe a circle as a set, say. Right? And we have a distance formula, right? So how do we write this using the distance formula? Take 10 seconds and write it down. If you see me going like this, it's because I have contact lenses. It's not because if I look strange, that's because strange or strange. What?
Too much coffee.
No. Yeah, if I look like I have coffee, it's not true. Just have contact lenses. Okay, who can tell me? What should I write here? This is the same thing as all points, such that, what's the equation? The distance is d. The distance of the point from x naught, y naught is d, in other words. Yeah? Nobody? Okay, turn to somebody next to you and say what you think.
No, that's distance. It's not. It's distance between these two.
You guys should know it. We did it last week. The
Yeah.
distance between 2
Oh,
points
right.
is d. Somebody, please.
She knows it.
Sorry.
It's the square root of x naught minus x whole square plus y naught minus 1 whole square.
Is d. Okay, right. All points in the plane whose distance to that center is d. Right? Or if you want to write it, if you want to square those sides, that's also legit. That's also in this case it doesn't change the condition. This plus this is d squared. It's the same set. It's the same set. Yeah.
I just have a really weird question. Why is it r squared when you write x and y?
In the plane, x and y are in the plane.
Oh,
R squared means you've got one copy of the real line and another copy of the real line. R2. We usually call it R2.
okay.
Yeah, don't say R squared. People will
Okay.
People will laugh at you and then they'll ask who your teacher is. So this is this is the formula for a circle, right? This is the formula for a circle, right? X minus x naught squared plus y minus y naught squared is equal to d squared. You've seen it before. It's very natural. It just means that your distance from x naught y naught is d. Right? I guess normally people write r instead of d and call d the radius.
So as long as you have 2 points, you can solve.
Say
As long as you have 2 points, you can solve the distance of a circle.
yes, yes. Well, no. I mean, if you have the center and another point, you can certainly figure out the radius, right?
Well, it'd be 2 points though, because the center would be a point.
Yes, but if I had say like these 2 points, then
Yeah.
it's maybe a bit harder to figure out what the circle is. Right? Unless you know which 2 points you have, you're hoping that one is the center. Okay. Right. Right. So let me just write it out. X minus x naught squared plus y minus y naught squared equals, say, r squared. Describes a circle of radius r about center x naught y naught. So, for example, if I gave you something like this, x plus 4 squared plus y minus 3 squared is equal to 1, no, is equal to 4, then you would be able to tell me, just by looking at it, what the center and what the radius is are. Think for 5 seconds. And then somebody tell me what they got. Tiffany?
The center would be -4, 3, and the radius would be 2.
Exactly. Because this x plus 4 is the same as x minus minus 4. Okay. So x minus 4 squared. So the x coordinate is, the center is -4, and then we've got 3.
She meant to let you could draw it.
Yeah, if you want to. Right, well, okay. 1, 2, 3, 4, 1, 2, 3. And you've got a radius of 2. If you want to. Okay. Okay. to give another example, somebody gives you something like this, 9x squared minus plus 54x plus 9y squared minus 6y plus 64 is equal to 0. And you say, okay, well, I'm just going to divide by 9 because I can divide both sides by the same number. I divide both sides by 9 to make this look more like something that I would like. So I get x squared plus 6x plus y squared minus 2/3 y plus 64 minus 0. These two guys have the same solution sets because I multiplied both sides by the same number, 1/9. And then I say, I think this is a circle because I've got this x squared and y squared here, and I've got some x's and y's and some numbers. I think this is probably a circle. So to recognize what circle it is, I'm going to make it look more like like this, right? And so you play the game of completing the square. And you say, okay, I want to make this thing look like the square of something, right? I want to make this thing look like the square of something. So I know that I've got to add on 9 to this, right? How would I make this x plus something squared, right? X squared plus 6, well, it should be like x plus 3 quantity squared plus 9, right? You guys see that? So I write it over here, plus y squared minus 2/3 y plus equal to 9. Okay. So you look at this thing and you say, okay, I want to make this look like x plus something squared. So you think, what should that something be if I've got 6 here, right? And you say, okay, let me think. X plus that something squared is going to be x squared plus what? 2ax plus a squared, right? And then you think, okay, so the 2a is 6, so my a is 3. Right? 2a is 6, so my a is 3. In other words, I take half of the coefficient on the x. Okay.
I thought you were trying to get to 6 then.
Notice that when I square this thing, I get x squared plus 6x, right? 6x plus 9. Right? Okay, so let me go back again. We see this thing and we say, how do we make this thing look like a square? Because we want to make this whole thing look more like the formula for a circle. So you see this thing, you say, oh look, well this thing, we can make it look like a square if we add 9 to it, right? So I'm going to add 9 to it. Okay. Recklessly, I'm just going to add 9 to it. And if I do that, I see that's the same thing as x plus 3 quantity squared. Okay. But I can't just add 9 whenever I feel like it, right? So I'm going to subtract 9 as well. Okay. Or if you want, I can add 9 to the other side. It's the same thing. Okay, and then I'm going to do the same thing here. I've got y squared minus 2/3 y. Well, what's the square that I'm going to want here? What am I going to do here? Well, maybe I'll let you think about it. What should I do here to make this look like y minus something squared?
do I 19?
Hey, you see, the reason why I keep such a blank face at all times, you may have noticed that completely blank face, so that you can never know if you're right or wrong. In fact, when I was younger, I had even less expression, even more expressionless face. Okay, turn to somebody else and see how you did it, how you make this thing look more like y plus or minus something quantity squared. And somebody? Okay, who would like to say?
Did you add 19?
19. Okay, so let's see. We'll say, well, you sort of know what's if you just follow the rule that I just erased, you'd say, okay, I'm going to take 1/2 of the coefficient here, and I'm going to square it and add it on. Right. So whenever you have something like, x squared plus ax, we just, as I just erased, right? X squared plus ax. Look, if I if I have, I'll write it slightly different. If I have x squared plus capital AX, and you notice that if I add on capital A over 2 quantity squared, then it becomes ax plus a over 2 quantity squared. Right? Because when I square this thing, I get this. Right? So whenever I have something like this, if I want to make it a square, all I have to do is take half of the coefficient on the x, and then square it and add it on, and then it becomes this.
Okay.
Okay. If you want a rule to follow. Okay. So I look at this thing and I say, okay, well look, the coefficient on the y, on the thing to the first power is 2/3. So I'm going to take half of that 2/3, that's 1/3, and I square it, and it's 1/9. Right? And again, I can't just throw in 1/9 whenever I feel like it, so I'm going to subtract off a 9. Right? Yeah. Lower.
So in the past, when I've done things for like in high school, instead of doing like the -9, can the 9 and the 1/9 just go over to 0?
The same thing. Right? So I either subtract 9 here, or I add 9 to the other side.
Okay.
It's the same thing. The main thing is that you want to do nothing to the equation, right? So I'm adding 9 to both sides, or I'm adding 0. I'm adding 0. Right? Both of those are equal. I won't change the equation, the solution set, if I add 9 the same thing to both sides, or if I add 0 to one side. Okay. So starting from here, we haven't changed the equation, but we've made it into a sort of nicer form, because now we recognize that this is x plus 3 quantity squared. This guy is what? What? Y minus a third quantity squared. Right? And then we have this 9, we have a minus a 9, we have minus 9, minus a 9, so it's minus, what, 82 ninths plus 64 ninths. Right? So minus 18 ninths, minus 2. So minus 2. Go ahead.
So how do we go from the y squared minus 2 times y plus 1 minus y is 1 minus to the y minus 1/3 squared?
This thing right here, right? We
Oh.
added on the 9 to
Okay.
turn this thing into a square. We completed the square. Now it's the square. Okay. So and then it's now really easy to read off what this circle is. Right? It's a circle centered at -3 1/3 and with radius √2. Right? So centered at -3 1/3 is the center, and √2 is the radius. Any questions on how we did that? We have these things. Yeah, this is already the equation of a circle, but just to make it look more obvious what that circle is, we decided to fiddle around with the equation. Right? So we make it say, okay, well, look, we can make this thing look like x plus something squared. We can make this thing look like y plus something squared by using the tricks of completing the square. You all look kind of happy. Shall I tell you a joke or something?
Yeah.
Okay, so the joke is that, periodically, this is not really a joke. But periodically, professors get to go on leave, right? They get like a semester off, say, like every 7 years or something, they get a semester off. And during that, so I had one semester off a few years ago, and during that time, I became even more expressionless. So like I was reverting back to my natural state, which is like completely expressionless. And so when I came back to school, I was like, what am I going to do? So I like put lotion in my face and to try to like make it more active or something. And the professor suggested, like ecology professor suggested the following. Newt Kopp, I don't know if you know it, but Newt Kopp suggested that I have a collection of masks. And like whenever I need an expression, I just reach for the mask.
Why are you so expressionless?
It's just my nature. And it's also quite useful as a teacher. So I should actually try to preserve that.
I'm afraid I'm going to get you really mad though, and I'm not going to realize that you're really mad.
This is me as fun. This is me when I feel yeah, but actually there's a tell when I'm really, really mad. If I'm really, really mad, then I lick my lips. So what, if that happens,
So you're going to look like after the first test.
just run away if you see me. Okay, so exercise. Here's x squared plus y squared plus 8x minus 2y minus 8 is equal to 0. So take at most 1 minute and see if you can do it. That's how long I give you on an exam. 1 minute. I'd probably give you 2 minutes, but not like 5. So. let's do it together, since we're running out of time. So I got the x squared, I got the 8x, I got y squared, I got minus 2y, and I have an h over there. So what do I need to add for this guy? 4 squared?
Yes.
16. What do I need to add for this guy? 1. Right? Negative 2 over 1, that is negative 1 quantity squared. Right? This is 8 over 2 squared. This is negative 2 over 2 squared. And then you just write down what it is. So this is x plus 4 squared. This guy is x minus 1 squared. And we have 8 on the other side. Oh, but I forgot. What am I doing? I forgot. I was being crazy. Right? I need to add on 16 and 1 to the other side. Otherwise, I'm doing something very illegal. Right? So you get 17, you get 25.
So just a minus 16 as well, or because you're just adding it?
You can either subtract it from I can either say 16 minus 16, 1 minus 1 here, or I can move them to the other side. Right? It's the same thing, like we said. If you want, we can do it. Right? So I have minus 16 here and minus 1 here. Right? And then I get x plus 4 quantity squared plus y minus 1 quantity squared minus 25 is 0. Right? Which is the same thing for the 25 on the other side.
Why do you need to subtract one? Why do you need to subtract the 16? I don't.
Because I can't just throw in 16.
But wouldn't it become the quantity? So it goes away.
Only because I added in the 16 though, right? I started from here, and then I added 16 to this, right? You know that the rule is that if you add 16 to one side, you have to add 16 to the other side.
So why don't you subtract it if you're already adding it?
You can do it either way, right? I can either say I'm subtracting 16, in other words, I'm adding 0. I can certainly add 0, right? Or I can add 16 to both sides. So I did it the first way. I added 16 to both sides first, and then people said, well, why don't you subtract 16? So I did it the second way. But you can do it either way. It's the same thing, right? If I have x is equal to 0, and then I add 16 to both sides, or I guess I haven't changed anything, or if I have x equals 0, and I add 16 and subtract 16, you notice it's the same equation. So the first way I added 16 to both sides. The second way I added and then subtracted 16. Either way is legal. You just have to make sure that you're doing something legal. Right? You can't, you can't just add 16 to one side and then not compensate for it.